A pollster wishes to estimate the proportion of United States voters who favor capital punishment. How large a sample is needed in order to be 95% confident that the sample proportion will not differ from the true proportion by more than 5%? Okay, so this time N is what we're looking for. This is kind of like problem 1, I think. When they say will not differ from the true proportion by more than 5%, they're talking about a margin of error. So they're telling us that the margin of error is equal to 5%, which is 0.05. And they want a confidence level of 95%. That's 0.95. We'll have to find N by working backwards from E. The equation for E is the critical value times, and we're working with proportions still, so that is going to be the square root of p hat minus p hat squared divided by N, and that's all within the square root. Our critical value is going to equal that negative IMV norm of whatever A over 2 is, A over 2. A equals 1 minus the confidence level. So in this case, it's going to equal 0.05. A over 2 is half of that, so that's 0.025. So 0.025 is what we'll plug in there. This will become equal to, let's find out right now, negative NV norm 0.025, 1.96, 1.96. We're going to use this formula to find N. So let's rearrange this. I can start by re-expressing this into something that'll be easier to work with. That's Z sub A over 2 times the square root of p hat minus p hat squared. Divide all that by the square root of N. And so now I know that square root of N is going to equal this numerator divided by E. So the square root of N equals Z times A over 2 times the square root of p hat minus p hat squared divided by E. And so now I know that N is just the square of all that. Z of A over 2 squared times p hat minus p hat squared divided by E squared. And we know what E is from, whoops, not right there. We know what E is from there. We found our critical value there. We just need to find p hat. And according to the text on page 331 of chapter 8, under example 8.16, they specifically say that when you don't actually know the sample proportion or it's not given, then when you're doing this type of a calculation, looking for sample size for a specified margin of error, just go ahead and assume that p hat is equal to 50%. So we are going to set, we're just going to guess, set it to 0.5. And so we're going to plug that in down here along with our Z and our E. So we have Z sub A over 2 squared. That's where it's 1.96 squared times, and I'm going to put this next part in parentheses, 0.5 subtract 0.5 squared, close the parentheses, and then divide by E, 0.05 squared. That equals 384. They give us 385. It's a little unusual. Okay. Okay, because the actual number was 384.16, even though rounding takes you down to 384. If you're counting whole people here and you got that little extra bit, you just go ahead and make that an extra person. So they're saying 385. And that guarantees that your margin of error will be 5% or less. Whereas if we did the 84, it might actually go over that 5% a little. So that's one thing to watch for on a test.